Welcome to the General Chemistry 2 class. This section is on intermolecular forces and liquids and solids. This lesson is about the type of intermolecular forces. Let's begin. In this lesson, we will describe and differentiate the types of intermolecular forces. Let us recall that condensed phase, liquids and solids consist of molecules having close distance among each other, causing attractive forces to significantly interplay with their properties. An intermolecular force refers to an attractive force between two molecules. This attractive force is short range, for example, significant only at moderately short distance between molecules. Moreover, it is weaker than covalent and ionic bands. Van der Waals forces are the weakest intermolecular forces arising from interaction between two neutral atoms or molecules. These attractive forces have two types. First, the London Bridge or the London Dispersion Force or LDF. Two, Dipole-Dipole Force or DDF. Consider an atom, a particle consisting of one or many electrons. On the average, the electron cloud in the atom is considered spherical. At any instant, electrons may move from one region in space to another, causing distortion to the electron cloud. The portion concentrated with electrons bears a negative charge, while the portion that lacks electrons bears a positive charge. The separation of charges in atoms or molecules causes distortion of electron clouds of adjacent atoms. The created dipole or body bearing two opposite charges is called an endorsed dipole. Such kind of dipole is transient, that is, exists only for a short period of time. The intermolecular force arising from these induced dipoles is called the London Disperse Force, or LDF. All atoms and molecules exhibit LDF. The strength of the intermolecular forces is affected by the ease of electron cloud distortion in an atom or molecule. This property is called polarizability. Bigger molecules Bigger molecules have more electrons than smaller ones. As a result, electron cloud of bigger molecules is easier to be distorted than that of smaller molecules. Thus, separation of charges is greater magnitude and LDF is stronger. Dipole-dipole force or DDF arises from the electrostatic interaction between two molecules having partial separation of charges, as observed in polar molecules. DDF is stronger than LDF because of the permanent separation of charges in polar molecules that creates a greater magnitude of attractive force. The strength of DDF affects by the magnitude of the molecule's net dipole moment, that is, its polarity. A more polar compound exhibits greater DDF, that a less polar covalent as a result of greater magnitude of partial charges, hence greater attractive force. Hydrogen bond is a special type of DDF, exhibited by molecules containing hydrogen attached by highly electronegative atoms such as fluorine, oxygen, and nitrogen. This intermolecular force is stronger than a typical DDF as a result of higher polarity of the bond between hydrogen and a highly electronegative atom. Intermolecular forces, which deals only with attractive forces between neutral particles or uncharged particles, are under a more general type of forces called interparticular forces. Ion dipole force is another interparticle force. It is an attractive force between an ion. It can be cation or an ion, and a polar molecule. The strength of ion dipole force is affected by the magnitude of the ion's charge and the magnitude of the net dipole moment of the polar molecule. For instance, a cation with a charge of positive 2 has a greater ion dipole force with water than a cation with a charge of positive 1 has. Moreover, ion dipole force between a cation and water is greater than the ion dipole force between the same cation and hydrogen sulfide, since water has a greater magnitude of net dipole moment than hydrogen sulfide. To summarize, intermolecular forces are attractive forces existing between two molecules. Different intermolecular forces are the London dispersed forces, dipole-dipole forces, and hydrogen bond. The attractive force between an ion and a molecule is called ion dipole force. And you have there the references for further readings. Thank you and God bless.